Right, so you want to go into something called center of gravity, right? So if you look at your ruler, it might be a little hard with the semicircle, but I'll make you find it, right? All right. So center of gravity, let's take a phone for example. The center of gravity is a point where the entire weight appears to act. So if it's a nice and uniform phone, then its center of gravity is normally being center. Right? If it's something shaped like look at this here. This bottle of water, right? If it were full, it might say the center of gravity is in the middle, but it's not full, it's somewhere around here. Right? So your center of gravity for something like this might be a little bit lower. Right? So based on the shape of the object and based on where the mass is distributed, that's where your center of gravity is. So what I want you all to try now, take a ruler. Take a ruler. Let's see if we can find that center of gravity. Because if we find that center of gravity, I don't know if you all remember the example from last week with the magic trick, right? If you were to find the center of gravity of your ruler, you would be able to balance your ruler out. The simple reason is that the moments on both sides be equal. All right. So take a ruler, take a phone, take whatever calculator, and see if you can find a point where the center of gravity is. Right? It takes some a little bit longer. Take a phone and try it. See if you can find a point where your center of gravity is. So if you get a balance your ruler, that's close to it. So yours leaning to the right. So that means you should go to the right a little bit more. Right? So yeah, close to it. Right? But ideally it should be done at a point. So you should be able to take a pencil and balance your phone on, but we won't do that. Right? Ideally, it should be done like that. Ideally. You can take your finger and try and balance it there. If you get it, that's the center of gravity. Because it's just one point. So yours won't be uniform because of your yeah. If you can find it. If you can do it at your fingertip or your pencil tip, that is the center of gravity. Try it in a ruler. Nah, not like that. Because when you use the entire finger, right? More like that. When you use the entire finger, it's different points to use. But if you use your fingertip, anybody get one like? So that's the center of gravity. Yeah, I can look. Right, and if you want to challenge yourself, take a pencil tip. Take a pencil tip and see if you can balance a pencil tip. Take a pencil tip and see if you can balance your phone on it. That will be an even more accurate value for center of gravity. No. You take in your fingertip and you balance your phone on the top right. If you find that, that's the center of gravity. Okay? So your center of gravity is not the same for all objects. Huh? If it's a nice uniform object, it's the middle. If it's not uniform, it's based on how your mass is distributed. All right? Right, so you can try a ruler and do that. Anybody remembers why balancing at that point? I explained it last week. Why it is when you use a ruler and you find your center of gravity. Right. Why it is when you take your ruler and you find your center of gravity, why it is a ruler balancing? Because the moments on. And one more reason. moments on both sides equal because of something. Where does your weight act? At the center of gravity, right? But right now the weight acting at the pivot. So if your weight at the pivot, the moment is, okay? So I want you to remember that as well. So the weight of the ruler acting down on your finger, and the finger have an upward force here. The upward force equals to your downward force. And the moment is equal. All right? So let's take a look at center of gravity. Let's see how to find it. Y'all did that experiment? Center of gravity on an irregularly shaped object. Yeah? Form 1 or 2 or something. Yeah? Write this, please. The center of gravity of an object is defined as the point on the object where its entire weight appears to act. For a uniform object, the center of gravity is in the middle of the object. That's if it's uniform, right? Right? And what you could do is draw a nice uniform object from it. Right? Draw a nice uniform object. Center, that's your center of gravity. And your weight will act like this. All right, so your center of gravity is that point in the middle there, right? So it kind of uniform now, if you can invest in a little protractor, compass center, like. Is that? So they have to fit some good. But second the other. I guess it was out 300. And with the textbook, I think as well. Right. What will happen now if we have something irregularly shaped? So let's just say, suppose you have something shaped like this. Then we're not too sure where the center of gravity is, right? So okay, what chairs do? What chairs do, and I'll show you the instructions before I will give you the method, right? What chairs do is just make about 5 holes. You make about 5 holes around it. All right, and then from each hole, you allow a string with a little rubber at the end to hang freely. So seen it there? Y'all seen it there? So as I have not none. No, on top of that. A little bit top after the part of the ones. Right. So on the first hole, right, you allow the string to hang, and right where the string is, or where the string was, you draw a line. Then you go to hole number 2 and do the same thing again. Then you go to hole number 3. You all will recognize that all the lines intersecting, right? Where those 3 lines, well, 5 lines intersect, that is your center of gravity. Are you okay with that? So from every hole, you allow the string to hang freely. So you do it here, you do it at hole 1, you do it at hole 2, then 3 and 4 and 5. If you do it properly, all the lines will meet at the same point. That point is what we call your center of gravity. Everybody okay with that? Right? And of course, you can't make the hole too big, right? Why? If it, right, because if it cuts a big hole out of it, it will change the weight, right? Right? So make sure the hole is nice and small. Right? 5 holes, draw them where they intersect. That would be your center of gravity. All right? You want to draw it. Draw this one before I give you the arm method. 3 holes, right? 3 diagrams, and then I'll give you the method. Heading is to find the center of gravity of an irregularly shaped object. It doesn't have to look exactly like mine, right? Close enough. Center of gravity of an irregularly shaped object. But this is only for something that's not uniform, right? Make it 5 holes and do the same thing for 5 times. Cover that.
Yeah.
Which one do you want? That's all right.
Hybrid.
Oh no, the other one is that. Ready? It's a small note, right? All right, so these are your 4 steps. Place the shape on the torch stand by using a pin and ensure it transferring freely. Right? These are the 4 steps we went through just now. All right, the bad news is you have to write this handout, not on the actually I can send it to you. I will send it in the group for now, right? Yeah, once every diagram, not good enough. Oh wait, no, I don't have it. All right, and you have to these handouts. Somebody them up. But I think that thank you. I will stop it. Then I can some. Right. Check in the group, right? So you don't have to write all of this, right? Right, so you don't have to write all of this. So no, none.
Yeah. Oh, that's nice.
Right? Place the object and so on, right? So the same things that we talked about, those are your 4 steps, right? Right. So why is stability important? Why is center of gravity important, right? So what you're saying. So the position of the center of gravity affects whether or not an object topples. A body topples when the vertical line to the center of gravity falls outside the place, right? So what does all this mean? All right, so I want to show you a little simulation here, right, to show what they are talking about here. All right, I ain't seen this thing, huh? I always think anybody else. Right. So why is the center of gravity important, right? So what you see, right? Can I see in that image? Right. So what you see? Let's say I gave you something looking like this, right? Let's say I gave you an object looking like this. If I left the object right there, will the object fall? No. The object wouldn't fall, right? Center of gravity acting right there. Everybody okay with that? But what would happen? What do you think will happen if I were to tilt it slightly? Or tilt it so much as yet? Just not. Let's say we tilt it a little bit, right? So you're pulling it to the right a little. And your center of gravity still acts inside here. What do you think will happen? Will it topple? No. Right? Once your center of gravity is inside this point here on the inside, you will recognize that it will go back to the original. But what will happen here? What will happen if I tilt it a little bit more? And then your center of gravity is outside of the piece here. What will happen? It'll tilt. So once your center of gravity goes outside here, outside of the piece, your object will fall. Right? Here it will remain stationary. Here, what will happen? Here it will return to what? Return to the original position. Here it will fall. It will fall to a new position. And it all has to do with the center of gravity being outside of this base here. So I have two questions. How do I make this more stable? How do I make this more stable? There are two things I could do. Ada? Which part?
Yeah.
Right, what will that do?
That will counteract the center of gravity.
Okay, close. What else I can do? So what he said is apply like a weight here and force could go back down. Yeah, that could work. What else?
That's what it means.
Very good. We can make the base wider, right? If I make the base wider, what will happen? It means it will take longer for the center of gravity to go outside. So I could widen the base. Right? And if I use what Adrian said, right? What he said is I could add a weight on. So if I add a weight on here, what that does is that lowers the center of gravity. For example, if I have a bottle of water, right? And the bottle of water full, and it's nice and uniform, where would the center of gravity be? Somewhere in the middle, right? But if I were to drink out some of the water, where would the center of gravity now go? A little bit lower. Right? So, question. Which one is either toppled over? The full bottle or the bottle that's halfway? The full bottle. Right? Try it and see. If this were full, it would have been much easier to topple it over. Now drink half of the water. And what you will recognize it wouldn't be as easy. Because it lower your center of gravity. That's okay? So two things I could do. I could widen the pace, or I could lower the center of gravity. Right? So if I lower my center of gravity, drink out some of the water and lower it, you'll recognize that it wouldn't fall as easy. That's okay? If I widen the pace like this, it wouldn't fall as easy. You okay with that? Yeah, so drink one half and see what happens. Everybody okay with that? So you see how important center of gravity is? Right? Question, who played basketball or football? What do you do if you're trying to go around a corner pass? Go lower. What will I do? It will lower your center of gravity. Right? Everybody okay with that? When else do you all observe this? Think of something else where you observe a wider base and lower center of gravity. Race cars, very good. Right. Race cars, nice and low to the ground, and tires nice and wide because it makes it more stable. Anything else? Anything else? What? A suitcase? Think of something else. No? There are plenty things where this is what we do to make it stable. Copy it down. Copy it down. And think about the next example. Yeah, those three diagrams just to show you what will happen. Right, so once the center of gravity goes outside the base, your object will topple. Or stable. That's the includes 2 minutes. Somebody. Cargo ships. Yeah, close Diego. Don't story, but activities. Ready? So what we're gonna do now is 12 questions apply this, right? So we're gonna combine what we did last week and today. Okay, please remember this, right? Right, that's just the lamp on our room. Right, you can publish sketchy diagram. Sketchy diagram, sorry to make it short so much today. Sketchy diagram, and then I'm going on to the question. So look at that there, right? They're going to ask about movements and they're going to ask about how we get to. Right, so here we have a lamp. The lamp has a weight and a foot F happening on it, right? So we're going to have to apply what we learned last week and this. And we'll pick somebody, we took somebody both. If they get the first one. Write down the mass. Write down the mass, 1.5 kilogram. Right, I think it just need one more bag. I'm moving up, eh? You all go down the mass. Mass is 1.5 kilograms, right? Right. It have a length and it carrying. Length is 0.18. Well, I get some to you tomorrow. I get 15 to you. Right, ready? After you draw it, right, you can go to question after. Adding is 0.18 earlier. Adding is 0.18. Boy, with that. What's behind that question? Can you move it? Question, right? If I apply a force at SA, where will become the pivot? Where will the pivot be? So you're applying a force at F, imagine it's a lamp, and you pull in the lamp at F. Where will the pivot be? Okay, that is the what I said. At the letter B, yes. Right? So it will be at the letter. Just bear that in mind, right? Right. Go ahead. Try this, please. 12 marks for that. Try that in. If you're gonna help us. Calculating weight, calculating movement. Ten minutes, right? And so far we can reach. Please don't forget SI units and use gravity in 10. Don't forget your SI units, right? Yeah, use gravity in 10. Anybody can tell me the definition for moment? Moment of a force is what? Force multiplied by distance from pivot, I would missing. Perpendicular distance from the pivot. Force multiplied by perpendicular distance from the pivot, underline the word perpendicular. Right, there's a reason I'm reminding them. Go ahead. Part 1, 2. Right, you should have to be by now. The people go blank. Blank, blank, blank. Adrian, you have my with the first one. So, where the forces? What they want it for? They want the movements of the weights. So let's start with the weight. Let's make sure you have that right. Right, Adrian, how we get the weight? Well, tell me now, how you find weight? Should know that formula.
Mass by gravity.
Excellent. Mass is 1.5, gravity is 10. So the answer is 15 newtons. But here's the hard thing they asked us tonight. How we gain the moment? Where is the force?
15 by 20, right?
Force acting there, right? What is the perpendicular distance from B? Oh, perpendicular means 90, right? 90 degrees. Sure, you sure it won't be this distance here? And that's perpendicular. Yeah, that's perpendicular. Right, next one is parallel. So perpendicular will be W to B. So that's how much? 0.9, right? Half of 0.18. Half, right? How I know it's half volume? Because we assume the bottom here, we assume it's middle, right? This shape nice and this shape is uniform. So we can assume it's in middle, right? So here is W and here is 0.09. So how do we find moment again? Moment is the force by the perpendicular distance. Follow why? You follow why we're using that distance there? How much is that? 1 point. It's for the one, right? Right. After the time. That's last. By the last one. If you want, like you can reflection the structure. Oh. And pass it on. Right. Same thing. How about street levels? Right. But it's a lot of agreements. Also go to the canister, right? Nothing. What do people want to do? They come extra. You're okay with that? I'm going back, right? Go ahead. Find part 2 and explain part 3. You can tell me with part 2, right? Part 2 a little tricky. The hint I given you in part 3, part 2, is look back at what we did last. That's the hint I will to give, nothing else. And part 3 is what we did. So look back at what we did before. So you have a horizontal foot S now. It's applying along XY, find the minimum value. Hmm? Yeah, we do four. Right, but think about it. Don't try to figure out when it falls over. Think about it in equilibrium. And then anything more than that will fall over. Right? So think about in equilibrium. Right? Think about it in equilibrium. That's what you'll come up with. Ignore before it falls over. Right? So if it's in equilibrium, what is the law we could use? Sum of the clockwise equal to the sum of the anti-clockwise. You have to figure out is X clockwise or anti-clockwise? Is W clockwise or anti-clockwise? All right? So F is what? Clockwise or anti-clockwise? Clockwise, and then W will be anti-clockwise. Go ahead. Have fun. Find for F. And have one more little trick in between. Oh, find for F. Right. I also yes. Right. So we said in part 2, we said that anti-clockwise moments is equal to the sum of the clockwise moments, right? Oh, we have to write pivot at E, right? Pivot at E. Nice question. Which one anti-clockwise again? W, right? And we already found the distance from E, right? That was 0.09. And which is clockwise? F. How far is F from the pivot? Perpendicular distance. Yeah. What's the perpendicular distance of F from E? F acting this way. Zero 0.36. Very good. Right? So perpendicular is 0.36. So F multiplied by 0.36 and then solve for F now. So I have 1.35 over 0.36. But find out how much? 3 point. Sorry. 3 point newtons, right? 3.75 newtons. Okay, so that is your principal moment. Yeah. Right. So the final answer here. So anything greater than 3.75. So your final answer is anything greater than 3.75 will positive tuple. Everybody okay with that? So remember your answer is not 3.75, anything greater than that. Okay? Huh? Yes, and you guys see now. I will ask somebody to explain part C. When you. Bye-bye. Part 3 is for you. Take your time. Part 3 is what we did today. Think about it, right? Part 3 is what we did today. For calculations. That's my explanation. Right? So I want to know how this increases stability. So they're gonna put a ring around here, right? They're going to put a ring around here, right? I enjoy it so good as well. Know what I mean, right? What will that do? It widen the base and right, because you're adding a mass in bottom. So it will widen the base. That makes sense? It'll make the base wider and it will lower the center of gravity. That's all. Right? So it will widen the base and lower the center of gravity. That's all you have to say. Right? Explain how it increases stability. The ring will widen the base and it will lower the center of gravity. That's all you have to say. Easy maths. Easy maths there. Right? So you will say that it will widen the base, the ring will widen the base, and it will lower the center of gravity, right? Since the heavy metal ring is placed at the bottom. I'm going to show you something as well, right? Remember, we just worked this out, right? What you see, I show you the numbers in it. What will happen if I add something heavier to the lamp? What will increase automatically? The weight of it, right? So this value will be larger. You're seeing that? That 15 will be much larger, right? So this value will be larger. So it makes the force F much larger. That's okay. So I want you to see the numbers in it as well. If I were to make the weight larger, it will make the force required to pull it down larger, which means that the object is more stable. That's okay. What else will become larger? Something else becomes larger as well. Remember widening the pace, right? So this will become larger as well because it will be further away. Okay, it will be further away from the pivot. All right. Anyway, I wanted to just show you that, right? Right. So that is your stability, and we have 3 types of stability to learn. and you finish, right? Watch this here. So there are three different types of equilibrium, right? Presley, right? You have three different types of equilibrium, right? We have stable equilibrium, unstable equilibrium, neutral equilibrium, right? Okay. Right? I'm going to try to explain each one, and I want you to try to draw what it looks like. Okay? So there are three different types of equilibrium: stable equilibrium, unstable, and neutral. Let's see if we can explain each one now. So stable equilibrium returns to the original position. Okay with that? Unstable, it goes to a new position. Neutral equilibrium, it stays in its new position. Right? So you have three different types. Right? You have stable equilibrium where it returns to the original. Unstable, new position. Right? Neutral, it stays in its new position. Stable equilibrium occurs when the object is slightly displaced, and when the release, it returns to the previous position. All right? Unstable is that the body moves away from its initial position when slightly displaced. And last one, neutral. The body stays in the new position when displaced. So what I want you to try is for each one of these, if we could draw a diagram showing each one. If you want, you could use a pool, a ball inside a pool. Right? We need to, sorry. I want you to draw an example of stable equilibrium, unstable equilibrium, and neutral. Right? Similar here. Similar. No. It's in your hand. It's in your hand. The diagram, not in your hand. Which do you think is which? Which one is which? And that's why I label. Which is stable, which is neutral, which is unstable. Right? First one is what, Solomon? Stable, because if we displace it, it goes back to the original. Lucas, second one. Neutral. You sure? Because if you move it away, what will happen? It will go back, right? It will move away to the new position. So it will keep moving. This one here is what? Think I different between both of them. This one moves away until it reaches that position of equality. So the second is what? Unstable, right? And the third is neutral, right? When you move it, it will stay in its new position and the center of gravity stays the same. Okay? Just make a note of that, please. In neutral, center of gravity stays the same. In neutral, anybody who doing physics with this school, jumping up your forms today? Who do it again? Who doing physics with us? Jump it up already? Adrian, who you doing physics with? You're writing private for the school. When are you writing for physics?
No, he's right, just follow this.
Follow it.
Yeah, how many more are you gonna do?
Yeah, yours already?
Right, side reach, okay,
Yeah.
It's just the ones that's, they don't have, the ones that needs to do.
Yeah, you form?
What?
Yes. You do next year or next year? Next year, oh. Anybody else? In neutral equilibrium, the center of gravity stays in the same. The center of gravity stays in the same position. All right. Nice. So that's it for stability and equilibrium from today. Okay. Next, we move into motion. All right, we go into motion next week. All right.